Okay, so today we're going to talk about solving absolute value equations. The notes that I'm going to do are going to be from page 65 and 66. Your assignment will be one page, page 68, and really the hardest problems that I go over with you guys here today are actually not on that assignment. So you should be all right with the easier examples here. So there's three things to keep in mind, and it's almost the steps to solving this, but they're more like things that you should be looking for. First, we want to make sure that the absolute value is isolated. For example, you want the absolute value to be alone on its side of the equal sign. There can be no numbers around it. So this would be a good example of an isolated absolute value. Here we have 3 times the absolute value of x is equal to 6. This is not isolated. Before we can move on to our next steps, we need to make sure that the absolute value is alone. We would do that by dividing by 3 on both sides in this case, and end up with the absolute value of x is equal to 2. Now that's isolated and we can proceed with solving it. Once your absolute value is isolated, we're going to write 2 equations. We'll write one positive equation and one negative equation. The positive equation is real easy to write. You're going to write exactly what the original equation is. You're just going to take the absolute value signs out. Then you will also write a negative version of it. You'll take the absolute value signs out, but you will change the value that is given to you to a negative. And then we will need to solve both of those equations, and we should end up with results of 2 answers. We're going to make sure that we write those answers as a solution set. For example, x is equal to the solution set -3 and 7. I put those numbers in braces, and I also put them in order from the lowest to the highest. So let's look at some easy examples, real easy ones right off the bat. First thing I see is that my absolute value is isolated. I can go ahead and proceed writing my 2 separate equations. My first equation, my positive equation, is going to be exactly what's written here with no absolute value signs. So x is equal to 2. My other equation will be the same thing that's written here with no absolute value signs, except I will make the 2 negative. So x is equal to -2. In these very simple examples, there's nothing we need to do further to solve for x, and so all we have to do is write our answer as a solution set. X is equal to the solution set, -2 followed by 2, putting them in order from lowest to highest. Let's do another one like that. I see that my absolute value sign is isolated. There's no numbers on the same side of the equal sign outside of the absolute values. So now I can proceed to write my 2 equations. My positive will be exactly what's written here with no absolute value signs. And now I write my second equation, exactly what's written here with no absolute value signs, but I make this 14 negative. M is equal to -14. There is nothing further that needs to be done to solve those 2, so I will write my final answer as a solution set. So m is equal to the solution set, -14 and +14. Let's take a look at one that actually involves a little bit of solving. Problem number 3, we can see that we begin again with our absolute value isolated. So I will write my 2 equations. I have 5z equal to 40, exactly what's written there with no absolute value signs. And I'm going to write my negative equation, exactly what's written here, with no absolute value signs, but I will make this into a -40. So 5z is equal to -40. So the next thing that I'm going to do is solve both of these equations. Now these are one-step equations. They simply have to be, both sides have to be divided by 5. I can actually solve these ones at the same time. I probably should have said that. This gives me a 1z, so z is equal to 40 divided by 5, which is going to give us 8. And this makes 1z is equal to a -40 divided by 5. I will get a -8. Now I need to write my final solutions as a solution set. Z is equal to the solution set of -8 and 8. One of the common mistakes that I see from students with absolute value is they'll get hung up on problems like this. They'll get one of the answers and then assume incorrectly, the other answer is just going to be its opposite. That'll be the case in these simple examples, but it will not be the case later on in some of the other examples that I do for you. So let's go ahead and take a look at number 5. It involves a little bit more solving. First, once again, my absolute value is isolated. There's nothing outside the absolute value signs on the same side of the equal sign. So I'm going to go ahead and write my 2 equations. My first equation is exactly what's written here. I just take out the absolute value signs. D plus 1 is equal to 8. And now I'm going to write my second one, exactly what's written here, no absolute value signs, but I'm going to make the 8 negative. So D plus 1 is equal to negative 8. Now in this case I do have a step that I have to do to solve these. It looks like I will need to subtract 1 from both sides. That gives me D is equal to 8 minus 1, which means D is equal to 7. I will again subtract 1 from both sides in my second equation, and I get D is equal to a negative 9. Now I need to write my answer as a solution set. D is equal to the solution set, negative 9 and 7, putting them in order from lowest to highest. Let's turn the page and look at some more complicated examples that they've given you. So here we go. Starting with number 9, we begin to have to first isolate the absolute value. So we're going to treat everything in the absolute value sign the same as you would treat a variable. So to isolate the absolute value, in this case I will start by subtracting 2. That gives me the problem. The absolute value of C is equal to 12 minus 2 gives me 10. And now that my absolute value is isolated, I can actually go ahead and write my 2 equations. Another common error is that students will attempt to write their 2 equations out right here at the beginning without isolating it, and it ends up getting them incorrect answers. So my first will be exactly what's written here, no absolute value signs. And my second will be exactly what's written here with no absolute value signs, but I will make this into a negative 10. So C is equal to negative 10. Fortunately for us, we didn't have to do any further solving in those. Now that I have my 2 separate solutions, I'll write them as a solution set. Negative 10 and positive 10. We have another example in 11 where we need to first isolate the absolute value. This time 6 is being multiplied by the absolute value of x. So what I'll do to isolate it is divide both sides by 6. This gives me the absolute value of x is equal to 4. And now that it's isolated, again I can write my 2 equations out. X is equal to 4, and now my negative 1, x is equal to a negative 4. Nothing else needs to be done to solve these. I can write my 2 answers as solution set. X is equal to a negative 4 and 4. I have a couple more examples for you here. Now this one is kind of got everything in it. Not only will I have to isolate my absolute value, then I'll write my 2 equations, but then I'll also have to solve those 2 equations. So let's take a look at this one. In this case, the absolute value is being divided by 6. So I will go ahead and multiply both sides by 6. And that gives me the absolute value of 2w minus 4 is equal to 18. Now that my absolute value is isolated, I can write my 2 equations. I get 2w minus 4 equal to 18. And now my negative version, 2w minus 4 is equal to a negative 18. Now in this case, to solve for w, in both cases I'm going to have to do a couple of steps. In this case it looks like I will first add 4 and then divide by 2. So let's add 4. That's going to give me 2w is equal to 22. And when I divide by 2, I discover that w is equal to 11. Let's do the second. I actually do the same 2 steps to solve it. I'm going to start by adding 4. But this time I get 2w is equal to a negative 14. And once again I divide by 2 and discover that m is equal to a negative 7. Let's write our answer as a solution set. W is equal to the solution set, negative 7 and 11. Now there are two scenarios here that I want you guys to see that you might run into. Problem 17 and problem 18 actually have the same issue, but it's a little bit more obvious in problem 17. First I look, my absolute value is isolated, that's great. But as I go to write my positive and negative equations, I notice that it's claiming that the absolute value of x is equal to -6. Now that should not be possible. Absolute values always produce negative or always produce positive numbers. Therefore, if you run into a situation where you've isolated the absolute value and it's set equal to a negative number, this is an example where you can jump to no solution. Now, we have the same issue here in problem 18, it's just less obvious. Even at first, I see a positive number here, I would think that I might have a solution. But let's see what happens when we isolate the absolute value. In this case, -3 is being multiplied by the absolute value. So I'm going to go ahead and divide both sides by -3. And once I've isolated, I end up with the absolute value of 2x plus 1 is equal to a -7. So we have the same issue as in problem 17. Absolute values produce positive numbers, and at this point I don't have to go further. I can recognize this as no solution. You'll see examples like each of these on your assignment, and please be prepared to ask questions in our Google Meet.